Hello, I'm Anil Kumar. Welcome to my series on inequalities. We know what are equations. We will learn what are inequalities in this particular video. We'll see how to sketch graph of inequalities and also how do we write equations from the graph itself. So now, what are inequalities? Well, something which is not equal to, right, will be an equality. For example, if I sketch a line, then any point on that line, which could be in general said as y equals to mx plus b, will be represented as a point on the line. It satisfies the equation. However, if we have a point which is not on the line, then what? It will be an inequality. What do I hear? That seems to be sound of a train, right? How far is it? Is it within 5 kilometers of my reach or beyond? Well, that will be an inequality, correct? How far is the train? You remember the days when we used to run to see the train? Well, now I think it sounds what inequality is. We understand. Today, what we are going to do is learn some basic concepts and we will see how do we plot solution of an inequality on a number line. We'll also see the reverse, that is, if we are given the solution on a number line, then how do we write the inequality? But more than that, we are going to understand how we can sketch graph of inequalities. So let me begin with the chapter. We did hear about the train last week when I'd gone out on a camping trip. I did see a train, and that's the picture from there. I was thinking about inequalities at that time. Well, the yellow line here represents the railway track itself. A bird flew past me, and this red line is the path of the bird. In between area can be written as an inequality. Do you see that? Something which is less than the line shown in red, right? And something above the yellow line. So that is the area, or we can say the region, which is between the two, right? So region between bird and the track, right? So we could represent this situation in the form of an inequality. You find it interesting? So now let's get into what really the inequalities are and how do we solve them. We'll begin with the very basic concept of inequality first. Here are four examples for you which I would like to discuss. Whenever we talk about inequality, in that case, we are looking at things which are above or below a reference point or a reference line. Do you see that? Normally, when we are sketching on a coordinate plane, as we have it here, we are looking above or below a curve, correct? So, if I have a curve which is kind of like this, then let us say this curve is represented by f of x. In that case, the region which is A shown here will be above f of x. So we can say that A is greater than f of x. Is that clear to you? The region which is below the function, let's call this b, so we can write that b is less than the function f of x. So that is how you could represent an inequality. Well, if you want to include the line also, in that case you can make the line darker. In that case, we may write this as, including the line, we may write this as a is greater than equal to f of x. You get the concept, right? So if we include the line, then It could be equal also and greater than. At times, we will like to shade it. So let me just highlight this area. So this area is what we are saying, that A is greater than or equal to the function f of x. So A is a region which is beyond f of x. You get the idea. Perfect. Now, we could have cases where the line is not included, as we had written earlier. So in that case, what are we going to do? Well, in that case, we are going to draw the line as a dotted line. So the function will be now represented by a dotted line. In that case, we use inequality greater than or less than. So that forms the basic. If the points are on the curve, it is equal to. If the points are above the curve, then it is greater than. And if the points are below the curve, then it is less than. And if you want to include the points on the curve, we use equal to also with the inequality. Correct? With this brief discussion, let's take 4 examples. So example number 1 here is, we have a diagonal line which is y equals to x, correct? So this line is y equals to x. You will note that we have a dotted line. Since this line is dotted, it means that in the inequality, line is not included. The shaded region, which is shown here, is above the line. And therefore, we could write the equation of that particular shaded region as the y values being greater than x. Does make sense? The line is y equals to x, and the shaded region is y greater than x. In the second case, which is example number 2 for us, we have the shaded region on the right side of x equals to 1. So you can see here that this dotted line is basically x equal to 1. Now, since the shaded region is on the right side and it does not include the line, since the line is dotted, we have the inequality which is x is greater than 1. Is that clear to you? Now, if y equals to 2, in that case we have a line which is shown here. However, this line is again shown as the dotted line. So in the inequality, the region shown above this line, as shown here, is an inequality which is represented by y greater than 2. Perfect. Here is the 4th example for us, right? So we did 3rd. We have a slanting line whose gradient is decreasing, negative slope. The equation of this particular line is x plus y equals to 8. Well, these two intercepts are at 8, right? So that gives us the equation x plus y equals to 8. The region shaded is where the y value is less than the equation of the line, and it is a solid line. Do you see this? It is a solid line. Therefore, in this particular inequality, the line is also included, and we can now define our inequality as x plus y less than equal to 8. You see that? So the line is included in this particular solution. So I hope you got the general concept of inequalities right in the very beginning. Correct? So I hope this concept is absolutely clear. Now let us see, how do we relate inequalities with number line? Well, before that, here are some very basic concepts of working with inequalities. Let's begin with the equation itself. Equation starts with equal to sign. Always in any equation, you will have an equal to sign. It really means, for example, the absolute value of minus 7 is 7. They are equal, right? And equation of the line could be y equals to minus 2x plus 4. All the points on the line are represented by this particular equation. Now, if I say not equal to, that is also something which is we will normally not say an inequality, but not equal to is kind of important. So not equal to is equal to with crossed with the line, and that is to say that 7 is not equal to minus 7, correct? Sometimes we are also looking into some graphs where we say, well, x square minus 1 is not equal to 0. What does that mean? Well, let me sketch the graph. X square minus 1 will be a parabola, right? So, and as it is x square minus 1, it is shifted down by 1 unit, and you will find that it has two x-intercepts. So, when we say x square minus 1 is not equal to 0, that means these 2 points which are at plus and minus 1 are not included. You get the idea. So the solution for this will be what? Well, the solution will be that x is less than minus 1, x is greater than minus 1 and is less than 1, and x is greater than 1. That is the solution, right? You can also write the solution as x belongs to real numbers where x is not equal to plus minus 1. You get the idea. So that is how we will use plus minus not equal to sign. You get the idea, right? So this is the application of not equal to sign. When we talk about inequalities, we are basically referring to these signs. So these signs are greater than. So this is the sign for greater than. It means 7 is greater than 5. You get the idea. When I say y is greater than something, that means above the line, right? So we can say this is above the line, right? And when I say less than, it is below or to the left side. Is that okay? So when I say less, it is below or left side. So that is these three. We're talking about inequalities now. So if I have less than, it does not include the curve or the line, but it could be under or on the left side of that particular curve. Greater than equal to will include the line, right? For example, all these numbers given here, 0, 1, 2, 3 and all are greater than equal to 0. 0 is equal to 0, correct? So that is how we could do it. We will see how to solve such inequalities as 2x is greater than equal to x squared. Similarly, less than equal to means the curve is included and everything below or on the left side of the curve is part of our solution, right? So that means below or to the left, right? When I say less than equal to. Perfect. So there are some common examples where we will be using inequalities. For example, if I say wage is less than $30 an hour, it's an inequality, right? It could be any wage less than 30, like 15, $20 per hour, mass greater than 75 kg, waves higher than 2 meters, temperature above 25 degrees Celsius, age less than 18 years, angle of inclination more than 15 degrees, marks greater than or equal to 90%, tolerance within 1%. So these are some examples where we'll be using inequalities. Now let's also see how do we represent solutions mainly on the number line using inequalities. Well, linear inequalities normally involve solutions on the number line. We have seen many times where these symbols are for the inequality, right? So instead of equal to sign, which is seen in equation, we have these inequality signs in any inequality. So here we have shown a number line. As you can see, if I write something like this with a filled in circle and the line moving towards the right, since the filled in circle is at 2, it represents that x is greater than equal to 2. Is that clear to you? So all the values greater than equal to 2 can be represented on a number line with the help of an inequality as shown here. If we have something less than 5, not including 5, then we say x is less than 5, then the arrow is pointing left from 5 and we have an open circle. So it is very important to understand these circles. This is open circle. That means not included. and this is a closed circle, which means included. So if you want to include it, you have to put a closed circle. Is that clear to you? Correct. Now, in solving inequalities algebraically, we follow the similar method as we do for equations. The only difference here is that when you multiply or divide by a negative number, in that case, the sign also changes. So what I'm trying to say here is that 7 is greater than 5, as you know. If I multiply by negative number, both becomes negative 7 and negative 5, and you know negative 7 is less than negative 5. Correct. So therefore, it's very important to see that when you multiply or divide in inequalities, the sign also changes. So the caution here is multiplying and dividing an inequality by negative number will also result in the reversal of the inequality sign. So with that basics, let's begin our chapter. Now here we have inequality and number line relation. Inequality can be described in words and represented on a number line, as we have seen, correct? Now here we have a table where one column is for inequality. We'll describe this and then graph it on a number line. So the inequality here is x is greater than equal to 2, which is described as x is greater than or equal to 2. On a number line, 2 is filled in and the line pointing right represents x is greater than equal to 2. Perfect. If x is less than 5, in that case, 5 will be an open circle not filled in and the arrow will be pointing towards the left. We could also say x is between two values. In this example, we have taken x greater than minus 1 but less than 7, right? So in that case, we have a line in between minus 1 and 7 with the open ends on the two sides, correct? The inequality, of course, is minus 1, which is x is greater than minus 1 and less than 7. The alternate way of writing this inequality is also using the bracket. So when I write this kind of a bracket, which shows open bracket, parenthesis, right? So minus 1 to 7, both minus 1 and 7 are not included. In the first case, when it was included, correct? In that case, greater than 2, see the square bracket. Square bracket means the interval includes that particular point, which is 2 in this case. However, infinite numbers are not real. They can never be included. So always the parenthesis will be as shown here. Correct? So this is kind of a review for you when you did inequalities of linear equations on number line. Now here is what we are getting into. So we'll see how do we write or represent inequalities and the graph. You can see that there are two different lines on this particular graph. One of them is dotted and therefore in our solution we will not include any point on this particular dotted line. The other one is the solid line. A point on the solid line will be included in our solution. The shaded region, if that is the solution, in that case point B is on the solution, correct? Is a part of our solution. The point D, A, C and E are not part of our solution, correct? C is on the right side of the solution, D is below, A is on the dotted line, means not included, and C is also below the dotted line, and therefore that will not be part of our solution, correct? So here we have summarized few important things about the inequalities. First, graph of a relation f of x represents all the points on the curve that will satisfy the equation or the rule for f of x. Solid line of a graph indicates that all points on the curve can be considered as a part of solution. Dotted line on the graph indicates that the points on the curve are not part of solution. Inequality solution set will be shown as a shaded region on the graph. Zero test. Now it's very important to understand what a zero test is. If 0, 0, which is the origin, satisfies the inequality, then origin is part of solution. it is an important test to check solution. So in this particular case, you can see that 0, which is the origin, does not satisfy the inequality. So we can substitute the variables x and y with 0 and see that the inequality is not satisfied. Perfect. That will show that the solution is correctly shaded, right? So here is a student's activity. So you can always take a picture of this, solve this question and post it. If you send an email to me, then I can always respond to your email. The question here is, write 3 possible inequalities from the given graph. B. Identify the points that will be part of the solution set for each inequality. Explain how zero test can help to check your solution for each inequality. It may sound slightly difficult at this stage, but you can make a note of this question and solve at the end of the lesson. Let's begin with some very simple examples. Example number 1 here is graph solution of the linear inequality y greater than x minus 2. So when I say y greater than x minus 2, what do I mean? I mean the points above the line, right? So we are looking for the points which are above the line. Is that clear? So since it is y is greater than x minus 2, we do not include line, right? So do not include line. That means we have a dotted line. Do you see that? So these things are important. Now everything which is above this dotted line will be part of the solution. So you can say shade it like this, correct? So that becomes the part of solution. So when you want to graph y greater than x minus 2, we should begin with sketching the line itself. So first step will be to graph the line, correct? So this is our step number 1. Step 1 is to graph the line. You can graph the line with slope and intercept since y equals to x minus 2. So at minus 2 we can mark a point and then the slope is 1, which means rise of 1 and run of 2, right? So we can go up, rise and run, and then joining these 2 points with a dotted line, right? So this is the dotted line. Simply because we are looking for an inequality which is greater than. Once you've done that, then we shade the region above, right? So we have shaded the region which is above this particular line, right? So once you do that, then we have the shaded region and that becomes the part of solution. Is that clear to you? So that is how we are going to represent the solution of any inequality. Now, we have shaded with a dotted line the region above to indicate y is greater than x minus 2, correct? So that is the inequality. Now here is zero test. What is zero test? If I substitute 0 here, then what happens? I get 0 greater than 0 minus 2. Is 0 greater than minus 2? Yes, it is true. And therefore, we notice that 0 is a part of solution. Since it lies in the shaded region, we are sure that our solution is correct, right? So by mistake, if you do the other side, zero test will help you correct your solution. Perfect. So now we can write down the solution set itself, which is the solution set is the half plane above and to the left of the line. The line is not included in the solution set. Perfect. That is how we are going to solve every question. So it involves basically 4 steps. So step number 1, graph the line. Step number 2 is to shade the required region, right? Is to shade. And step number 3 is to do the zero test. And step number 4 is to write down the solution. Is this clear to you? So these are the 4 steps which you have to perform each time when you are graphing inequalities. So now let's move on with example number 2. I would like you to pause the video, answer this question and then look into our solution. So what are we going to do? Well, the question is to graph solution of linear inequality y less than equal to minus x plus 3. So see, we have y less than equal to minus x plus 3. It means we are looking for below the line, right? And line is included. Line included. Is that okay? So that is what it is. Line included means solid line. So step number 1 is sketch the graph of the line y equals to minus x plus 3, and then step number 2, shade the required portion, right? So when you shade, remember the line has to be solid. It is to be included as shown here. Do you see that? Now, zero test. If I substitute 0 here, then what do we get? We get 0 is less than equal to 3, and that is true. 0 is indeed less than equal to 3, and therefore it lies in the solution set. So we are sure that our solution is correct. So we have done the test, and now we just need to write down the solution. The solution is, the solution set is the half plane below and to the left of the line, correct? Line is included in the solution set. So clearly we are writing it so that no mistakes are performed, right? So no assumption. Similarly, we'll do many examples. Here is example number 3, equation being x plus 2y equals to 8, and the question being that you need to graph equation of x plus 2y less than equal to. So again, we have a solid line as shown here, and less than means the side below it. Step number 1, sketch it. You can sketch using x and y intercepts. So we know x and y intercept should be 8 in this particular case. You can always find this. The x-intercept is 8, right? And the y-intercept will be 8 divided by 2, which is 4. Join these 2 points to get the line. Since it is less than equal to, we go below the curve and to the left side, that is shaded. So that is the first part. Second part we shaded, and third part is the zero test. If I substitute 0 here, then we know 0 is less than equal to 8. It is a part of solution. So that is what we get here, and then we need to write down the solution. That is the region including the line which is under or on the left side of the line. Similarly, you can do all these examples. So let this example be kind of a test question for you. We need to do 2x plus 4y greater than 6, correct? Of course, the line will be dotted. We are looking for a solution above the line. Example number 5. Now we are including more than one line in our question. So the question 5 here is graph solution of linear inequality 2x plus 4y less than 6, y greater than 0, x greater than minus 1. So now in this case we have to see a common region. So we are looking for intersection. Is that clear to you? So which is common to all of them. So at y 2x plus 4y less than 6. Since it is less than 6, we will have a dotted line as shown here. So that is dropping down. So this is the line 2x plus 4y which is less than 6. Means we are shading this portion. Is that clear to you? Correct. As shown here on this particular side, let me shade the region which is below the line shown, correct, which is 2x plus 4y less than 6, right? Let me just shade it further, full, right? That's okay. Okay, just increase this line. Perfectly fine. Now we have done the first equation. The second equation is y greater than equal to greater than 0, right? So again it is a dotted line, but this time we're looking into portion which is above the x-axis, right? So this is the portion which we are saying is greater than y equals to 0. And the third condition here is x is on the right side of minus 1. So this is the line x equals to minus 1, and on the right side that is the portion. Is that clear to you? So clearly the intersection of all the three is formed by the triangle shown here, right? So this triangle shown here is the intersection part. So we can now shade this particular region which is common to all the three, and that becomes part of our solution. You get the idea, right? So that is how we do it. So we have done the first part, which is graph the solution. Part B here is list a point P which is part of the solution. So now you have to find a point P which is part of the solution. Well, in this case you can find any point which is within, right? So we can say this point here, which is, let us say, 0 and 0.5 or 0 and 1. These are part of solution, correct? You can say 1 and 1 also, right? 1 and 1 is not there, but 0 and 1 and 0 and 0.5 are part of solution in this particular case. So we can say that the point P is, in this case we wrote 1 and 1, which is part of solution. We could have written many other points also, correct? So that is how you get the solution. Now we need to write down a point R which is not a part of solution. So we see that the origin itself is not a part of solution, since we have to look for something which is on the right, which is above y equals to 0, right? So that is the dotted line. So this point B is not included. You get the idea. So origin is not included in this particular solution. Perfect. So that is how you could actually solve this. I hope this point is absolutely clear, right? So now let's look into more examples where we have more than one line. So once again, there are three different lines. Treat this as a test question. So you need to sketch the region which is defined by the three inequalities: x plus 2y greater than equal to 1, solid line, line included; y less than equal to 4, and x less than equal to 3. Again, a region found will be a triangle which you can figure it out. And once you do that, once you've done the graph, then you have to list a point P which is part of the solution, and also list a point R which is not a part of solution. You get an idea, right? So that is how you would actually do this particular question. I hope this concept is absolutely clear, right? Okay, so let's move on with more equations. Now this time what we are doing here is we have a multiple choice test paper. So this is test for you. So we had the earlier questions. Now here we have multiple choice. I like you to pause the video, answer this question, and then look into our solution. So question number 7 here is, find equation of the inequality from the given graph. Okay, so we have to find the equation of the inequality. So we're given many inequalities here, right? We're given many inequalities. Select the one which is helping us to find the solution. So this is the solution, the triangle. Now which equations are involved? Well, we do see that that is the x-axis, correct? And we have this as the y-axis. So this region is above the x-axis. That means x is greater than equal to 0 is one of the equations, correct? Now, this is above the x-axis, means that y greater than equal to 0 is one of the solutions, correct? Equation of this line is y equal to 0, right? So the inequality will be y greater than equal to 0. Now we are looking for the other point, which is on the right side of 2. This line is x equals to 2, right? So this portion which is shown here is x is greater than 2, right? Since it is a solid line, it is x greater than equal to 2, right? So the portion y greater than equal to 0 is the one shown here. Now the third one is below the diagonal line, which has a slope of, we'll figure this out, from 2, it is going down by 2 and then it's going right 2. So it is minus 1 is the slope, right? You could also see from the intercepts that the intercepts are 4 and 4, right? So that is x plus y is 4 is the equation of the line. Since we are on the left side, we know it should be less than equal to 4, correct? So this line is x plus y equal to 4, and the region which is defined here is x plus y less than equal to 4. So these three inequalities when combined will give us the solution, right? So we have these three solutions. So we have the three inequalities, which is x plus y, which is less than equal to 4. We have x, which is greater than equal to 2, and y, which is greater than equal to 0. So that forms the set of inequalities which give us a defined region. So I hope this concept is absolutely clear. So in this multiple choice test paper, there could be more than one solution. In fact, you have to identify all the inequalities which will lead to the solution given here. Perfect? Once again, you have to follow similar steps. The question now here is, you have to write the equation, write the inequality from the graph. So that is what you need to identify. We know we are looking for a region which is above the line, so basically need to find the equation of the line and then circle what should this be, right? You could use the intercepts to find the equation of the line and then solve the question. So I'll leave that for you. So that is for you to do. Similarly, we could have quadratic equation. Why restrict ourselves to the linear equations, correct? Now, inequalities can be done with any function whatsoever. So here is an example. We are looking for two lines, one line and a curve. Well, the line here is a horizontal line which is going through 3. So we can say this is y equals to 3, correct? So let me write this as an equation here, y equals to 3, but the region which is shaded is under this line, correct? So this region is y is less than equal to 3 since we have a solid line, correct? How about the parabola? Well, find the equation for the parabola also. The equation of the parabola could be written with the help of this vertex, visit at 1. And if I go one step, it is 1 here. So it is y equals to x square minus 1, right? Now, since we are going above it, so the region above it will be what? Well, everything above it is kind of like this. Is it okay? So this is shown by y, which is greater than x square minus 1. Correct? So that becomes the region which is defined for you. Correct? Now these two things combined together give you the inequality. We have to identify the right answer. So what we have here is that the function is this portion, which is x square minus 1, right? So we are looking for something which is above this, right? X square minus 1, and which is below y equals to 3. Do you get the idea? So x square plus 1 has to be greater than or equal to 3. That is how we are getting into this equation. You get the idea? So we have the graph of the parabola which is above and the line which is y equals to 3 in between. So in between, the common portion which has been highlighted is represented by the equation 3 is less than equal to x square minus 1. That gives us option B as the correct option. Do you see? It becomes complicated when I involve some curves, right? Parabola, which is simpler relative to many other equations. So we have involved a horizontal line y equals to 3 and the parabola, and then seen how does that work, right? So in general, what is happening here is we are looking for two particular ways of writing this. We are saying above one curve and below the other curve. You get the idea, right? And we are interested in the region which is between the two. Perfect. So that is how we are trying to write down the equation. So that gives us the right equation in this particular case. Is that clear to you? Now let's move forward and see more of this kind. So here is your test question. We have a curved line which is a parabola. You can find the equation of the parabola, which seems to be what? Simple equations we have kept. This time it is y equals to x square minus 2 since the parabola has moved down, correct? So that is the equation of the parabola. The line is diagonal, which is going through and through. So this line is y equals to x. Can you identify the correct answer for this? The line is above the parabola, right? So the y values which we are interested in are defined by x itself. And so whatever we have here, x squared minus 1, that should be below means less than x. And that should give you the solution, less than equal to, since it is a solid line, right? So we have solid lines, so we have less than equal to. Identify, so this is, I'm leaving this for you to do. Question number 11 is very similar. Once again, however, this time we have involved three inequalities, correct? So we're looking for a solution which is shaded here this time, and you need to find the right solution for this, correct? Question number 12. So this time the question is, how many points with integer coordinates will satisfy all the following three inequalities? Sketch the graph to confirm your answer. So we're looking into three inequalities. Y greater, let me rewrite, y greater than equal to 3x minus 1, and then we have y which is less than 1, and we have x which is greater than equal to minus 1. So the two are solid lines, one is not the solid line. You need to sketch and then find out how many integer points, right? You get the idea. For example, if I write 0, 0, you can check whether 0, 0 will be a part of solution or not, correct? So if I substitute 0, it may be the part of solution. So you may start with 0, 0 and then look into this. I hope it makes sense, correct? So with this, we come to an end of our video. Now, you can actually solve these questions, send an email to me, and then we can share these solutions with you. I hope you find it interesting and useful. So today, what did we learn? We learned how do we solve inequalities when we have many different equations involved. There could be linear equations or there could be equations with non-linear functions, like we took parabolas. We could have many equations at the same time. So I hope you found this lesson interesting and useful. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.